Hello and welcome to the class on basics of lasers. This is a session 1 and I will be teaching you the photonics part of your paper, optics and photonics, and this deals with the description of laser, and then there will be some topic related to fiber optics also. In the third module, this is the syllabus, absorption and emission of light. Absorption, spontaneous emission and stimulated emission. So we will see various excitation and de-excitation mechanisms which will take place in a material medium, and we'll also see how we can use or modulate these kind of transitions in order to get a laser output. And there are two reference textbooks that you can use. The first one can be used as a basic textbook. That is an introduction to lasers, theory and applications by M.N. Avathanulu. It's a small textbook. It's a simple textbook which you can read and understand without much effort. The second one is also simple. It is also by Indian authors. And that will be used. Second textbook is Optics, Subramaniam, Brijilal and Subramaniam. So that is a textbook which you can use for all the three modules, whereas for the photonics part or for the laser part, I suggest you use the first one by M.N. Avathanulu. So in today's session, we will learn special features of lasers and the process of absorption and emission. I have selected these pictures just to give you an idea about how a laser device will look like. There are lasers of various size and shape and various power outputs. For example, these three pictures that you can see, they are very simple and very small and lightweight laser devices which you can hold in your hands. And the operation of these lasers is also very simple. You just have to press a button and the laser light will begin to come out as a continuous wave. And if you turn on this device, you will be able to see the difference between the output that we can get from a laser and the output that we will get from an ordinary lamp. See, this is a photograph of the laser when it is operating. It is giving the output, and these lasers are just like the simple and small lasers which I showed you in the previous slide. And you can see that when we turn on the laser light, you can see the emission light is having a unique color. Each of these devices is giving only a single color output. That is one feature of the laser. The output will be of a single color, or it is referred to as monochromatic. Mono means single, chroma refers to the color. So the first and foremost property of a laser is that it is highly monochromatic, which means it will contain a single frequency, ideally single frequency, but we will see later that it will be composed of very closely spaced frequencies also, but still it is considered to be the most monochromatic or the highly monochromatic light source that we can have. And another feature that you can see is when you are turning on the light, turning on the laser device, you can see the light is propagating as a single beam or as a single arrow. It doesn't get diverged. You can see the size of the laser spot very close to the laser device and far away from the laser device is very small, and it doesn't enlarge. You can think about the light which is coming from a torch. The size of the spots will be small near the torch, but far away from the torch it will diverge and will make a very big circle, whereas that does not happen in the case of laser. The spot size is the same near the laser and far away from the laser source. So that is another important feature of the laser. This is referred to as highly directional or very less divergence. So the second property of the laser light is it is highly directional or it is having extremely small divergence. So this is another photograph of a laser. This is actually a very big and huge heavy laser which is giving an extremely high power output or energy output. And this is actually the photograph of the inside of a laser which is called Nd:YAG laser. This you can see some green light over here. Nd:YAG laser is capable of emitting green light, which is actually a result of a nonlinear optical process. But what is important is that compared to the previous pictures I showed you, this is a very huge laser which you cannot just it's not very easy to move from one place to another place. um, but it's giving it's actually a very important laser which is used in nonlinear optical research. You can see when it is operating, it can create a lot of heat, and you require a separate water cooling system so that the laser will continue to operate without problem. This is actually capable of giving out infrared frequency and green light and UV light. So this is an important laser, and it's very heavy, and it's a high power or high energy laser, because this is not giving continuous wave output. This is referred to as a pulsed laser. So for the case of pulsed laser, it is the energy which is important, whereas in the case of a continuous wave laser, it is the power which is important. And this is a picture, it is actually a diagram, not a photograph, of another laser which is called the ruby laser. You can see the green color. This is the laser beam which is coming from the laser device. It is the red color laser. Ruby is also a pulsed laser, and you can see this helical tube. It is actually a helical flash lamp which is used for pumping, something called pumping, which I will explain later. And inside this helical flash lamp, you can see a red color crystal. That is actually the material in which the laser operation is taking place. So this is also historically, ruby is also an important laser because it is one of the first lasers which was successfully operated. Therefore, to sum up the special features of lasers, I have listed them out as 5 different features. Actually, there are 4 of them. I will just read out. The most important property of laser light is that it is of single color, or it is highly monochromatic. And the second one is it is having almost zero divergence, or it is highly directional. The second and third point is pretty much the same thing: zero divergence or highly directional. And the third one, I have listed it as fourth. It is coherence. Laser light is having extremely high coherence. Coherence means the wave trains which are coming out of the source. Each of the wave trains will be traveling in such a way that the crest and crest will match, will be at the same phase, and the trough and trough will coincide, so that there will be zero phase difference between various wave trains. So that is referred to as coherence. Laser devices having the extremely high coherence. And the last property is high intensity. Laser light is having extremely high intensity. You can see, if you remember the second feature, when you are turning on the laser, all the photons will be traveling in the same direction, and all the photons will hit the same spot if you allow to fall it on a screen. Therefore, the intensity that is experienced by at that location will be extremely high. For example, if you compare it with light coming from a bulb, and suppose you just imagine a bulb on one hand and laser light on the other hand, and just imagine that both these devices are emitting 100 photons. In the case of a bulb, all these 100 photons will be traveling in all possible directions, whereas in the case of a laser, all these 100 photons will be traveling in the same direction. So at that location, if you measure the intensity, all the photons will contribute to the intensity, whereas from a bulb, all the photons will be hitting different spots, and the intensities will be very low. Whereas the same number of photons, since they are all traveling in the same direction, will create a huge intensity if it is coming out from a laser. Now, so what is laser? It is actually a short form for something called, or it is referred to as an acronym for something called light amplification by stimulated emission of radiation. So if you learn the meaning of each of these words in this acronym, you will be able to understand what laser is and what is the reason for all the unique features of the laser. So that is, in order to understand that, there is probably a new term that is appearing. This is the stimulated emission. So that is what we have to learn. What is, you'll have to understand what is stimulated emission. Are there any other kinds of emission? In order to understand all this, you will begin with absorption and emission. In order to understand what is absorption and emission, I have used two diagrams that you can see on the left side and the right side. It is essentially the nucleus and the orbitals around the nucleus and electrons in various orbitals. It is actually from some atom. It is the electronic arrangement in some atom. And on the left hand side, I try to explain what is absorption. You can see in the case of absorption, you focus on this photon. See all these not helical, this zigzag arrow refers to a photon, and two photons we have used of two different color just to indicate that they are having different energy. Orange color is having higher energy and red color is having a lower energy. So on the diagram on the left, you focus on the photon which is having red color. You see that photon, it is going through the material and it interacts with the electron in the second orbit, and this photon will be having some energy. So when it hits this electron, it can transfer its energy to the electron. So the electron or the atom will absorb that energy and the electron will go to the third orbit. So what happens is that the photon has transferred its energy to the electron in the second orbit, taking that electron to the third orbit. So in that process, this photon will disappear and the atom will move to an excited state. Similarly, the orange color photon that we have used in the diagram on top, you can see that photon will be absorbed by the atom in the first orbit. Since it is having higher energy compared to the red color photon, these electron can be taken to a still higher orbital. From first orbital, it is going to the third orbital since the energy transferred is higher, and in that process also this photon will disappear and the atom will go from a lower energy state to an excited state. This process is called absorption. Whereas on the right side, you can see the reverse of this process. Similar to the previous one, if you look at the red color photon, what happens is that initially the electron is in the third orbit, the electron which is drawn near the red color photon. So what happens is that initially the electron is in the third orbit, and when it is in the third orbit, it is in a high energy state and higher energy levels are unstable, which means the electron cannot stay there for a long time. Somehow it will try to come down to a lower energy state which is more stable. So that is what is happening here. This is the de-excitation process. This arrow indicates that this electron is moving from the third orbital to the second orbital. There is only one electron. It is just for, just to understand, two electrons are drawn. It is not two different electrons. It is just a single electron which is moving from the third orbital to the second orbital. So it is a de-excitation process. The electron is moving from higher energy to lower energy. So in that process, it will release energy in the form of a photon, and it is coming out as a photon like this. And similar to this, if you on the top side near the orange color photon, you can see the electron which was initially in the third orbital is de-exciting to the first orbital, and it is releasing a photon of higher energy which is shown using this orange color. So these two processes are two examples of how photons can interact with electrons, or how light can interact with material. Photon means light and electron is one of the subatomic particles in material. So electron actually stands for material. So these are two examples of light matter interaction between light and material. So in this session, I would like to sum up the session 1 here. We have seen some special features of light, and the paper title of this paper is, in your syllabus, this paper is Optics and Photonics. So you'll have to think about what is the difference between optics and photonics. Both will deal with light. Optics, you have something, it is a branch of science which you have already learned at many stages during your schooling. Optics deals with light, and when we say photonics, photon is also light, so it also deals with light. But then there should be some difference between these two branches of physics. Optics deals with any kind of light, whereas photonics deals with man-made light, which is having unique features, or the light that's treated in the subject category of photonics is referred to as engineered light which we purposefully create in order to have some unique features. So that is the difference between optics and photonics. The laser light is having many special features, and some of them are monochromaticity, directionality, coherence, and intensity. And the light will be produced due to de-excitation of an atom from an upper level to a lower level. Now in the second session, we will see other type of light matter interaction. So far we have seen absorption and emission, but we haven't seen what is stimulated emission. So that is where we will that is what we are going to focus on in the next session. We will see what is the difference between stimulated emission and ordinary emission, which we call spontaneous emission. And after explaining that, I will try to explain how a laser operates. So when you learn the operation of laser, you will see what are the basic requirements in order to construct a laser, and then we will see a special feature which we call the population inversion, which is mandatory in the case of laser operation. So that is what we are going to learn in the next class.